Hi everybody, welcome back to the last video on rational inequalities. So this does have a nice lengthy procedure, but a lot of it mimics the procedure used to graph rational functions. So a lot of it is not unfamiliar, especially steps 3 through 5. So let's do this procedure here, but one thing I want to note in particular is number 1. Set one side of the inequality equal to 0. This is very important. If you do not do this, you are not doing the problem correctly. So, let's start off with this example here. We're going to solve this inequality. So, what did I just say? Make one side equal to 0. So, I'm going to move the 1 over x to the other side. So, I'll get 1 over x squared plus 8x plus 12 minus 1 over x is greater than or equal to 0. And the whole reason for making one side equal to 0 is now we just want to find the values of x that make this side positive. Or 0. Because that would just make this greater than or equal to 0. So that's the goal for this problem. So basically you just reduce the problem down to finding signs on a number line. So first thing we have to do is simplify this fraction. So it will be x minus x squared minus 8x minus 12 all over x times x squared plus 8x plus 12 is greater than or equal to 0. Now you can also do the factoring in this step, which I am going to do. So I need two things to multiply together to be 12, but sum to 8. So let's see, factors of 12, and so we need to find the factors of 12 that add to 8. Well, that's simple. That's 6 and 2. So in the denominator we'll have x times x plus 6 times x plus 2. And then in the numerator we'll simplify. So this is negative x squared minus 7x minus 12 is greater than or equal to 0. I'm just going to multiply through by negative 1 to get rid of all the negatives in the numerator. So we'll have x squared plus 7x plus 12 all over x times x plus 6 times x plus 2. And this is going to be now less than or equal to 0. So we will have an x. So we need factors of 12 that add to 7, so that'll be x plus 3 and x plus 4 all over x times x plus 6 times x plus 2, and we want this to be less than or equal to 0. Very good. So notice that the simplification and the factoring can all happen in kind of one step. So now we need to record information about this function. So we need to know about the numerator. The zeros are at x equals negative 3, and it has multiplicity 1. And x equals negative 4, again multiplicity 1. So I'm just going to use mult again. And then the denominator, we'll have x equals 0. X equals negative 6, and x equals negative 2, and these will all have multiplicity 1. So now we draw a number line with all these numbers on it. So we'll have 0, we'll have negative 2, negative 3, negative 4, and negative 6. And remember what I said was that the numerator gets solid dots, and the denominator gets open dots. So this gets an open dot, and the open dot. And what this is supposed to remind you is that in this case we're going to have equals. So when you have equals, you always include the solid dots in your answers. If you don't have equals, you exclude the solid dots. And note that we always exclude open dots. So now we have to pick some sort of test point here. So let's figure out what f of 1 is. because that will tell us the sign on this interval here. So notice before we do that this breaks this up into a lot of intervals. This is going to be 0 to infinity. We'll have negative 2 to 0. We'll have negative 3 to negative 2, negative 4 to negative 3, negative 6 to negative 4, and negative infinity to negative 6. So these zeros of the numerator and denominators are the only places where a sign change can occur. And they don't always necessarily do occur, but these are only the only potential places that they can occur. So if I figure out, for example, what f of 1 is, that will tell me the whole sign on 0 to infinity, because the only time it's going to be able to change is as we cross this direction past 0. So we figure that f of 1, well, we go up to our f, I guess in this case, is going to be our big factored form. And so let's just plug in 1 everywhere. So we'll have 1 plus 3 times 1 plus 4 all over 1 times 1 plus 6 times 1 plus 2. And I don't really even care what the number is. All I care is all those terms are positive, so that means that this is going to be greater than 0. So this whole entire interval here is positive. And now, because everything has multiplicity 1, every time I get to one of these dots, we'll change signs. So this interval will be from negative 2 to 0 will be negative, from negative 3 to negative 2 will be positive, from negative 4 to negative 3 will be negative, from negative 6 to negative 4 will be positive again, and then from negative infinity to negative 6 will be negative. And so once you know the signs of each one of the intervals, you just go back to your inequality. Is it greater than 0 or less than 0? Since it's less than 0, we want all the negative. So our answer then is just going to be negative infinity to negative 6. And since this is open, we'll always exclude it. Union, again, this is open, so we exclude it, negative 4. But since we have an equality here, we are going to include the negative 3. Union. And then our last negative interval is from negative 2, which we'll include because the equality sign, and 0, which we'll exclude because it has an open dot. And this is our answer here. So notice the whole trick of this is just to figure out what the zeros of the numerators and the denominators are, which break up the interval, the number line, into these intervals, and where these zeros of the numerator and denominators are the only places the function can change sign. So once you know the sign on one interval, you can easily determine the signs on all the other intervals, and then you just pick out the intervals, in this case negative, that you want that solves your inequality. So that's all there is to graphing rational inequalities. After you do it once or twice, this will become second nature and very easy, so don't give up, because a lot of students do give up on these type of problems. And I will see you in class.